So we're going to start considering how the calculus interacts with these functions of several variables. So z equals f of xy. So we'll just be looking at, for the moment, functions of two variables. That's still more than we did in the beginning of calculus. And we're going to start with the foundation, limits. So if you recall, we had this concept. There's many places I could choose to start here, so I'm just sort of jumping into a place where an experienced calculus student might remember some details. If you had two functions and you substituted a value into both functions and you ended up with 0 over 0, then we would say that this limit as x approaches c of these two functions is, and the term was indeterminate. Now, indeterminate is a word in English that just means I don't know. Cannot be determined from this information alone. 0 divided by 0 has some strange features. This may be undefined, it may have a value, and it could vary the types of values. And you've spent a significant amount of time studying that in the first year or so of calculus. So let's just jump into sort of one of the more famous examples when calculus begins. If you can recall, here was a case that was the 0 over 0 indeterminate, the limit as x approaches 0 of sine x divided by x. This limit happened to be 1. From calculus 1, we might say. We prove this, and there's a couple of different ways to prove it. You can verify it with a concept called L'Hopital's rule. I'll write that later. There was no nice algebra trick for doing this. There was just the reality of it was kind of an interesting little function. Now, we still had some tricks. So we had some algebra tricks that we could use. So let me just now jump into the multivariable calculus where we are. And if I took a function of two variables, x minus y over x squared minus y squared, and if I had both x and y approaching 2, so the coordinates of x and y get closer to the point 2, 2. If I try that substitution again, I'm going to get that same 0 divided by 0 taking place here, called indeterminate. But we knew that we were allowed to use algebra tricks for limits if there was a way to reduce the fraction. So we could say limit xy approaches 2, 2, and I could factor the denominator and then reduce that fraction. Limit xy approaches 2, 2. When this fraction is reduced, it's 1 over x plus y. And if x and y are both approaching 2, 1 over 2 plus 2 would be 1/4. So there'd be a limit there. So here's the first question. What if we have no algebra trick in mind? What if we don't have an algebra trick to resolve the issue? There are some algebra tricks that could be taught. We are not going to focus on them in this course, but there are algebra tricks out there. Even the book will share a few, but they only work if the problem is just right when it comes to fitting a particular description. I'm going to add a little bit of more bad news. What if we have no algebra trick? That's kind of bad news. Sometimes it's called L'Hopital's rule for a single variable. So we don't get to use it in here. Now there may be an extension if you were to do some serious searching around. I mean, the internet is a pretty vast place. But there will be no L'Hopital's rule for our particular course. So here is the question. What are we supposed to do about this? If the coordinates x and y approach some point and the limit is L, that condition can only be met if and only if. Remember, this is an abbreviation if you've never seen it before. For every epsilon greater than 0, there exists a delta greater than 0, such that if the function is within an epsilon of the limit, that means your x and y coordinates are within a delta of the initial x and y coordinates. That's a way you could read this statement aloud and try to make some sense out of it. This statement basically says if x and y get close to some point, then the function gets close to some number. Remember, that's another way of saying the z-value. This is how we say it in mathematics. How are we going to deal with limits with two variable functions? That is the question. So, stay tuned.